I think there's time for a quick round of applause for our musical accompaniment. They keep blowing my mind. Thank you, thank you, thank you, thank you. All right, I am here to introduce a dear friend of mine. Fun fact that I wonder if anybody picked up on. The title, Graphs All the Way Down, is inspired by one of his and my favorite authors' books, Turtles All the Way Down. John Green, may have heard of him? No? Yes? I see nods. Awesome. So Graphs All the Way Down is, from what I gather, a tale of the valley of tears and sky-high euphoria of dealing with Neos 9 beta. The highs and the lows, and here to show us and tell us all about that is Micha. Come on upstairs. Upstage. Or stairs.
Both. It's
Thank you.
actually both.
Don't forget to vote.
Hello. Can you hear me? Yes, great, awesome. Hi. Thank you for joining me on what is going to be a somewhat deeper dive into the inner workings of Neos 9. This is me. It's the same face, it's just a little more red. I'm Micha. I work as a senior full-stack dev at JVM Tech in Zurich. You can find me on GitHub, or you can find me in the Neos Slack sometimes when I remember to check it. And I'm here today to talk to you about a couple of things, actually. The first thing is I would like to show you the first and, to this day, largest Neos 9 project that we worked on. I want to share some of our experiences with Neos 9, and especially the early betas of Neos 9. Then I would like to tell you something about Neo4j, a database system, and I would like to talk about the content graph. And last but not least, a tiny topic I would like to talk about, space-time. So let's go. The project I want to tell you about is, we did that for a customer, Bern Expo, which is a Swiss exhibition venue in itself, and also a large organizer of exhibitions in Switzerland, one of the largest, actually. And they approached us, I think in 2022 already, but by the time we got actually to implement stuff, it was 2023. And they came to us and they wanted, for one, a user-friendly booking platform for people that wanted to host a stand at one of their exhibitions. They also wanted an elevated editing experience for their personnel when they enter data about the exhibitions and prices and packages and everything. And they also wanted an extensive data hub, so they wanted an open interface where they could interact with the data and use that stuff in other platforms that they provide, like their website. The result is this. That's very horrible resolution. I'm sorry about that. It's basically a booking platform. You can imagine it as just like any other booking platform, except for the fact that the data that they use and they provide is way more complicated than your regular shop system. It won us 2 Best of Swiss Web Awards, which is kind of nice. This is what it looks like with even less pixels and in a flow. So you walk through the platform, you select an exposition package, you configure the stand that you want to use, and then you configure a lot of details about the stands, like how many outlets you need, how many lamps you need, if you need red carpet, green carpet, blue carpet, everything around stuff that could be useful to an exhibition stand. And then you book it, and it goes through, and then you're done booking. That's basically the gist of it. How did we do that? We used not so microservices. Even though the architecture was meant to be layered, none of those layers is a microservice. They're very big services running heavy applications, but they're layered on top of each other. So it's technically sort of a microservice architecture, but not really. I guess it's a relatively standard stack. We use MariaDB, MySQL, Redis, Neos, Flow, a GraphQL application interface layer, And on top of it, the thing you just saw is a Nuxt.js-based front end. We run that with our hosting partner Upsun, so it's cloud hosted, it scales decently. It's hosted, and that was the important part, with Google Cloud, but in Switzerland, which is a very important thing for a lot of Swiss companies, that their stuff is hosted in Switzerland. And we run that based on Bitbucket or GitHub interchangeably, depending on what you're working with. The stack kind of looks like this. There is a let's call it editorial backend or an editorial admin interface that's built on the Neos UI. So all the interaction that editors have with the content is actually in Neos. So we use the Neos content tree, the Neos UI, everything to work with the content. Underneath it, we have the content repository and the untranslated Datenbank. I guess you can figure out what that is. Curiously, flow is usually in those schemas. Flow is always portrayed underneath Neos, but we actually use it as the data provider. So all the data is put out via flow controllers and not via Fusion prototypes or something else. And on top of that, you have the GraphQL API that then delivers content as a GraphQL schema to the different frontends. So let me talk about Neos 9, because this was built by choice on Neos 9, for one, because we wanted to be future-proof, and for another reason, we just kind of wanted to try it. And it turns out Neos was and still is a pretty damn good platform to do editorial work. You guys all know that. You've used it multiple times. It just does this stuff really good. And we thought so too, and we almost never regretted that choice. So what we did was basic stuff. We had structural logic encoded in NodeTypes, so basically all the transposition of what they wanted to how they interacted with it was done in NodeTypes. We did a lot of relationship bundling, so the stuff that you saw in the first slides is made up of very complex data units, so stuff is very intertwined with each other. There's a lot of rules and conditions that apply based on what you can select and what you can't select, and all that is done in the Neos backend. And as I just said, we did the business logic or the transformation of all the data to be output to the API via flow controllers. And we interacted with the content graph and the subgraphs directly. I'm sure you've heard this sentence a million times before. What we did was meant as a stepping stone. This was never meant to be a permanent solution. We initially released this to the public in September of 2024, and we called it the MVP. So this was just like the first step, and we were going to iterate on that architecture, and we were going to extend it and add different layers to it. And yeah, then our client decided that they don't have the money for that anymore, and so we kind of went into like an extended maintenance agreement with them where they had some budget to extend the system, but there was no budget to completely rewrite it or extend it in a meaningful way. All we did was tack on more features that they wanted, which made the system even more complicated. And so what started out as a platform that just hosted one exposition and like 4 packages and a couple of services now hosts, I don't know, 25 expositions with thousands of services and almost 100 package combinations that all have their own dependencies and their own conditions and their own rules on what you can book and what you can't book. So what went wrong, I guess, is what you could say. Where did we stumble? And to be honest, we might have been a bit optimistic about how good the betas were. I don't want to dunk on anyone because they did amazing work, but the early betas just, they were okay, but they were struggling. And so we started out with the development in early 2024, which was around the time when beta 13 was released. And we upgraded to beta 19, and by the time that we actually went live, we were on beta 19. To this day, because of budget constraints, it's still running on beta 19. We haven't had the budget to upgrade to an actual 9.0 release. And beta 13 had severe issues with publishing, rebasing, and discarding, and it could just screw up your entire content repository, which meant manual resolution. You had to delete events because content streams were getting lost. That was very annoying. At some point, our hierarchy relations table, I think this was at beta 16, was about 1 million rows for, I don't know, 7,000 nodes. So there was a lot of relationship handling going on. And this large database, in conjunction with hypervised cloud hosting, meant that the performance actually degraded a lot. So it got very slow. Working in the backend was a chore, running the front end was a chore, and that was not sufficient. So we couldn't publish this like that. So what did we come up with? We actually, remember, this is not built on Fusion, so there's no integrated Fusion caching. We needed to do this all by ourselves. And we came up with a completely separate caching layer in Redis, where we actually did a fully manual caching of all composite DTOs. So what we did was we created domain transfer objects that transformed stuff from the CR and then pushed it to the API via flow controllers. And what we did was we cut out the database completely at that point, and we were caching everything in distinct Redis objects. We're doing a full cache rebuild after every publish to live because we don't know, it's way too expensive to solve all the dependencies the objects have in themselves by the time that we publish. And we changed the editor workflow because after they published, they needed to wait for a couple of minutes until the entire replay was actually done and they could use the new content. And this worked. It still works. The system, if you use it right now, is using that exact cache layer. But we kind of realized that this cannot be the end-all be-all solution to our performance problems. So what did we do? We looked into different solutions. And one that came up was Neo4j. I've titled this The New Kid in Town. It was the new kid in town for me because I had never heard about it. It's not the new kid in town because it's about 25 years old. Graph databases are very old. They're not new stuff. So what is Neo4j? Neo4j is a graph-native database. So your data is stored as a graph. Every relationship is stored as an edge, and every object knows about its connection with other objects. Those relationships are native. There's no index lookup. There's no joining happening. A node just knows if it has a relationship, and it knows where that relationship points. It's very highly optimized for graph traversal. So if you need to look up a deep graph, it's very good at that. And it has pretty good performance, even if the database scales a lot. Like, it's really able to handle actually millions of relationships and then 10,000s of nodes, and it doesn't budge. It has a very nice query language. I mean, you guys probably know SQL. You use it all the time. It has a query language like that. It's called Cypher. It's very powerful. There is a learning curve, but it's not that complicated. One thing that kind of excited me was the fact that they have built-in procedures for data science. And data science kind of sounds like something you don't need for a content repository, but data science also means a lot of algorithms that deal with paths. So the traversal of a tree gives you a path, and it has very, very good procedures for that. And it's fully open source. It hasn't always been open source. It was founded in 2000. It was only made public in 2007, but it's been open source ever since. There is a software as a service offering that the guys that invented it do. It's called AuraDB. It does better clustering, higher performance, and everything, but the core and the Cypher language and all those procedures, they're open source. It's based on Java, which probably doesn't matter to a lot of hosters because if your server is able to run Elasticsearch, it can run Neo4j. So why use it for Neos? I've talked about graphs a lot already. Neos has a thing called the content graph, and it is, in fact, a graph. So it's basically a match made in heaven, because Neos stores nodes as nodes, and then there's the relationships which are stored in the hierarchy relations. Those can be used as edges in Neo4j, and it works really well together. And in our case, one of our biggest performance bottlenecks was the fact that we did a lot of relationship lookups. So we needed to do a lot of path traversal. We needed to figure out which node is referenced where, is this node referenced there, how does this interact with this, restrict the relationships and everything. So this is very good for that. This is actually only part of the object logic that we have. So every arrow is an interconnection in some way, and so you can see there's a lot of relationship handling happening. So there's a lot of stuff that is related to other stuff and restricted by other stuff. So what did I do? I wrote a complete new content graph adapter that replaces MySQL MariaDB with Neo4j. So I basically took the Doctrine DBAL adapter, looked at it, looked at all the interfaces, and implemented it completely. So it's meant to be used as an actual drop-in replacement for the current DBAL adapter. You can just install the package, and it mostly works. There are some bits and bobs that don't work perfectly, but it kind of works. It just uses the same event log that the current content graph does. So you have, in Neos 9, we've heard about it a lot, you have the event log that is like a replay of everything that happens in the CR, and everything you see in Neos is a projection of that. And we do the same thing. It handles, I said that, nodes as nodes. They're called nodes in Neo4j as well, and those those relationships are handled as edges. And yeah, it implements all the interfaces that the CR requires. So you can use all your queries, you can use flow query, everything just works out of the box. In this thingy-mabob, you see the blue ones are the ones that you actually need to implement in case you want to add your own database to Neos. It's 6 interfaces that you need to implement. Those are all implemented in the DBAL adapter as well. And Robert said this in his keynote this morning. If you take a look at the codebase on Neos 9, and I think this deserves a big round of applause, the codebase is awesome. It is really good. The interfaces are clean. Everything is structured. You just go ahead, you take the interfaces, and you implement everything that they're supposed to do. And that worked really well. Nothing is hidden. Everything is exposed via an interface, and you can just use it. And then you plop in one factoring method, and it just gives you an entire CR from a different database. One cool thing that you can do with Neo4j is, I talked about them, those like data science procedures, path algorithms for very complex lookups. And the next slide is, if you need to find a subtree in SQL, this is about what it looks like. It uses the Doctrine Query Builder. There is 3 different entities that you need to instantiate to actually figure out what your path is looking like. And this is Neo4j. This is the entire query that you need to build an entire subtree. And that makes it very easy to understand. It makes it blazingly fast. And I think it's a lot easier to maintain because it's not a lot of code. And it does stuff like that in a lot of places. So I'm going to be an idiot, and I'm going to show you. Yes, this is a terminal. This is a Neos 9 instance that has the new adapter installed, and I have a couple of scripts that I reset. I'm just going to reset the current CR, and then I'm going to create a Neos site. This is just flow site create. And it creates my user. So now what we have is, I could have reset that tab had I prepared, is Neos. This is just a regular Neos backend, and I can log in. And then I have a rather empty page, but it's Neos. And this is all running on Neo4j. And to prove that, I'm going to show you what happened in the database underneath it. Neo4j comes with a very nice Explorer type thingy where you can run queries against the actual database. And if you just want to see what's going on, you can just look at it. And so this is the current content repository. This is everything that is inside my Neos instance at this point. And you can see you can see the hierarchical relationships. You can see that there's multitudes of them because this is a multi-language instance. And so there's a discrete relationship for every content stream and for every dimension. And so this ends up if you have your root node, it basically covers all the combinations. That's why there's a lot of relationship. This yellow thingamabob is basically my root node. You can drag this stuff around. It's kind of fun to play with. I also store dimension points, which are just detached at the moment. I don't know what else to do with them because I just need to look up what's in the JSON blob after it's done. But I would like to set up a bit more complicated thingy. I'm just going to import the. This is going to take a second. I'm going to import the demo site. Import site is what I called it, I think. Yes. So now I'm importing the Neos demo page, which you've probably all seen about 1 million times. And wait, there's a database. Oh, you can. One caveat: you still need a MySQL database because I didn't replace everything. So everything that Flow does, all the account stuff, everything, and also the event log is still in an SQL database. These are all the events that happen to make up the content repository like it is. But you can see there is no projection tables because those are not necessary anymore because they are in here. And now this is what the CR looks like. It's a bit more complicated. There's a bunch more nodes, but they're all, again, hierarchically, they're all connected. I don't like that word. And so what you can do now is you can query that thing. I just need, it's very tiny. I need a content stream ID. I'm just going to use this one. And I'm going to plug it in here. Just give me 1 second, please. Now I think I broke it. Like that. And I need a dimension space point hash. I'm just going to use this one. By the way, this is the dimension space point hash for English US. I've seen those so many times that I can decode those hashes. And so if you go ahead, I'm just going to plug this in. I'm just going to set my parameters like that. Those are the ones I'm going to use. Whatever. And let's say you want to find a node that you want to find a node. But you don't just want to find a node, but you want to find a node aggregate. In case you don't know the difference between a node and a node aggregate basically is like the bucket that covers all the actual nodes underneath it that show in different space points and in different content streams. And so if I just, again, this query language is, I'm going to match, which is Neo4j for select, everything that is of label type node, which I've chosen to use for nodes for obvious reasons, that has the aggregate ID that I just put into a parameter. And I'm pretty sure that I made a mistake because the content stream thingy is wrong, but it shouldn't matter. There you go. It's one node. You get one node. Apparently, this one doesn't have different languages. I don't know, just picked a random aggregate ID. But you can also do the same thing, and for that, I actually need to fix the parameters that I just entered. No, they're OK. I didn't say a thing. What if you want to find a node in a subgraph? In this case, in a subgraph means in a specific combination of content stream and dimension space point. Nope, I don't want to go back to demo time. I just actually want to go here. You just extend the query. This is, again, I'm looking for a node with that same aggregate ID, but I'm now selecting for a specific relationship. and that is, I called it isChild. You can name that whatever you want. It's again just a label, but I'm looking for one that is in a specific content stream and in a specific dimension space point hash. And then I can run that query, and there is an error because I missed something that needs to be like that. And now I need to run it. There you go. There's no node found. That's dumb. Hang on. Just need something that actually works. Again, I'm just going to get all my nodes. You will be my target of choice, and then I'm going to be setting my parameters again. If I may not. Okay. Kids, this is why you don't do live coding. It never works. I've prepared all of this, and now it doesn't work. Oopsie, thank you. See, that's the power of community.
You're doing great.
You know what's the worst thing? Is people watching you type.
Yeah, don't be stressed by that.
Having people, no, that was wrong. I think this should be good. Yes, so now we can try that again. I'm gonna use the same query that I just did, and it should not do that. Again, don't do live coding. And there's still the same error because I didn't change it from the last time. I'm a copy and paste master. So, yay! We have a node. But that's kind of boring. What's actually fun is looking up relationship, because I kind of want to know where this node is attached to, because I need to find the parent, and I also want to see the visualization of the relationship. So what I'm going to do is I'm going to also return the parent node that I'm looking for. And then it looks like that. And now you have that node I was actually looking for. It's that one down there. Those are all of its relationships, and this is the parent node. And you can do that multiple levels if you want to, but you can also just look up the entire parent path. And it's just, I've showed you that, it's just one query. It's a bit more complicated, but it's not rocket science. What this does, I'm using one of those algorithms. This is just, I'm not going to use the shortest one right now. I don't want to know how deep down in the content graph it actually is. I just want to get the entire path. What I'm using is a path algorithm. That's why I'm assigning p equals, means the p is just a name, but it means assign everything that you find with this to a variable. And then I'm looking up, this is kind of hard to see, but I have a pointer. I'm not using an arrow, I'm using a plus. This means just walk up the tree until you find something. And I'm just walking up the tree until I get to a root node. And now I just need to press this button. And I didn't find anything. Why didn't I find anything? I do not know. Kids, don't do live coding. Shit. Why is it not working? Because I think I'm missing this. Maybe? Please? Yes, thank you. No, it doesn't find any nodes. That is really dumb. Wait, sorry.
We trust you that it works, basically.
Yeah, I've tried it a bunch of times and it worked. What it's supposed to show is a very nice graph. I'm not going to show you a very nice graph. If you want to see a very nice graph, I can rerun this demo when I'm not stressed the fuck out. And you can take a look at this. But what it was supposed to do and what it should have done is pick the node that I selected with its aggregate ID, and then it just traverses up the entire path, and it gives you that entire path as an object, and you can work on it. Just to prove that it still kind of works, I need my Neos backend, and it's going to be mad at me because, no, right, I destroyed the sessions. I'm just going to log back in. And as you can see, it all still works. This is all based on the new database, so you can see the entire backend. You can make changes. It handles workspaces and everything. I can just go in here, and I can replace this with, I don't know, some random stuff, and it notices that I've got changes in my workspace, and I can publish to the live workspace, and it all just works the same way you expect from the current database implementation. So that's that about the demo. I'm sorry about the paths, but whatever. I have one more thing that I want to talk about, and that is sort of a vision for where this could go. Because simply doing the same stuff that MariaDB already does is kind of pointless. But I had an idea, and my actual plan was to have this done by the time that I got here, which obviously didn't work out. But I would like to take the content graph one step further and put it into space-time. The idea is to use the power of Neo4j and its very good performance with a lot of nodes and a lot of edges to actually not only show the current projection of the content stream, but actually show, skipping ahead, show all of the events that happened in the CR at the same time and just use that one database. Because currently there is no rollback mechanism that is very easy. You can replay up until a certain point, which actually has been removed in the public release, I think, which I was very sad about because I needed that a bunch of times while I was doing this. There's also no historical state. There's no easy way to get back to the state that you were at a certain point in time. But what if nodes had a notion of their temporal position, so they knew in what version they were actually created, changed, deleted, moved everything in. So you just have one graph above the content graph that gives you access to every version that the content repository could provide because it knows about it. It just doesn't project it. And so you take a projection and you assign it a certain point in time, and you can just replay that. You could use it with a random slider that just gives you times of day, and you roll back and you just get every node that has been changed up to that point. Why would you do this? I didn't, but why would I do it? Firstly, because we can, because it's actually possible with this database. It doesn't care about it. But also because it adds business value to the product. For a lot of companies that are mostly publicly listed, it's important to have a history of what they did with their website. They need to be able to prove that at a certain point, certain information was on their website to ensure that no one accuses them of stock market manipulation, for example. So you need those rollback mechanisms. And currently, what I did, what you probably also do, is like incremental backups that just give you a certain state at a certain time so you can replay that and then get access to the thing. You wouldn't need that anymore. You could just use the SpaceTimeGraph and just roll back your CR to a certain point. It also allows for great content auditing. You can just check back what someone did, and you can get data back, and you can just copy it and put it back into the up-to-date content stream. You can debug stuff that happened in the back end. And I think that's kind of cool. So where do we go from here? First thing, let me reiterate. Actually adopt Neos 9 in your projects. It works surprisingly well now. We did all the testing of the betas that didn't work for you, so you don't have to anymore. You can actually use it, and it does a lot of stuff really, really good. But the second thing is, I've actually published this adapter. It's on GitHub. You can check it out. And I'm very, very welcome to receive feedback, to receive ideas, to receive PRs if you are so inclined, because the current implementation is kind of a mess. My queries are not optimized. I just made it work. And so there is a lot of performance gains to be had. I would just love for people to check it out and see what the code does. Maybe just use it as a jumping off point to do your own implementation for something else that you think is better suited for this application. But just look at it, test it, maybe install it. You just require it and then does everything else. You don't need to do any changes. I do not recommend this for production use right now. Do not do that. It's a very, very early beta, maybe, because it does everything, but don't use it. And that's it. Do you guys have any questions?
They have questions.
Wait. Oh, my slide is gone. Can you put my slide back up?
Pleasure to work with you.
Yes.
All right, so before I get into two questions, no, one comment and a question. Before I get into the comment, I was watching some of the Giga nerds. Sorry, I say that with so much love. Reacting, and Sebastian, I counted. Sebastian Kurfürst said, "Das ist ja krass." I counted 14 times. And he wasn't alone in that reaction. And lo and behold, I opened the response page, and it says, "Thanks for making Neo4j adapter a reality. We always thought we'll do that when we have some time. So a huge thanks from Sebastian." And then we do have one question, actually like refreshing. You have like a few more seconds if you think of something now. Would you still use the debug adapter for any projects, or is Neo4j just better in every way?
Yeah, I think I answered that with the last slide. Currently, yes, I would use the debug adapter. If someone came to me, make me a Neos 9 website, of course I would use the debug adapter, because this is not ready for prime time. I would try to make this better, fast, so I could use it because I actually enjoy using it. But again, yes, don't use it for production right now. This is like a 0.01.
All right, and in terms of the code that you mentioned not being production ready,
yes.
May I introduce you to Mr. Messi? He can help out with that. All right. Thank you so much. Actually, there's a gift coming from somewhere. One final refresh of the questions. No more questions.
That's OK. Thank you guys for having me.
Thank you so much. Ha. I'm just going to be over here while can I just... Yeah, there is, after I release them. All right. In 20 minutes-ish, we will have a talk here about how the Drupal community did the impossible possible. And on the studio stage, our friends from Kaufmann Digital are talking about a Neos SaaS platform. Thank you so much. Go check if there's any ice cream left over. Have a coffee, have some water. Hydrate, kids. It's very warm out. And then we'll see you back here or upstairs, stage stairs. It's the heat. It's the heat in about 20 minutes. Thank you so much. Oh, vote! Vote!